So today we're going to go ahead and talk about acceleration. So acceleration is the rate at which an object changes its velocity. The rate at which an object changes its velocity. So an instantaneous acceleration is just an acceleration at a split instant of time. Or maybe I should say, instead of split, I'll say specific. Perfect. Average acceleration is just your average acceleration over a time interval. So the equation we'll use to calculate average acceleration is an A with a bar over it. And again, the bar means average. It's going to be change in velocity over change in time. And our change in velocity is going to be Vf minus Vi over delta t. So to change our velocity, you can either, so to change velocity, let's think about what you can do. You can speed up, you could slow down, or you can change directions. So keep that in mind. If you change directions, you are accelerating. Cool. So now we're going to go ahead and look at a couple quick little examples for acceleration. Okay. So I would encourage you to go ahead and try filling out this table yourself, and then pause the video and then check back in after you try it yourself. But after you check back in, I'll go ahead and explain my thinking for it. So, okay, let's look at this column. So let's look at the first one. Object moving in a positive or negative direction. So what direction object moves is only told by the velocity. So if the velocity is positive, it means it's moving in a positive direction. If velocity is negative, it's moving in a negative direction. So in this case, the velocity is positive, so it's moving in a positive direction. Let's look at the sign of average acceleration. I'm just going to calculate it. So it's average acceleration is Vf minus Vi over delta t. So final velocity in this case is 8 minus initial is 4 over 2. So that will give us what? 4 over 2, which is positive 2. So this is positive. Great. And in this case, is the object speeding up or slowing down? Well, it's gone 4 to 8. So it's getting faster. So speeding up. Cool. This next one, an object's velocity changes from negative 6 to negative 2. The velocity is negative, so it's moving in a negative direction. Let's calculate average acceleration. So Vf minus Vi over delta t. So let's see, Vf is negative 2, Vi is negative 6 over 2. So this is going to be positive 4 over 2. Oh, another positive 2. Cool. So now in this case, oh, interesting. Okay, it is slowing down. So you're going from negative 6 meters per second in a negative direction to negative 2 meters per second in a negative direction. So you're getting slower. You just happen to be moving in a negative direction. Slowing down. So let's look at this one. So an object's velocity decreases from 12 meters per second to 8 meters per second. If they're telling us the object's velocity decreases, reader knows it's slowing down. I don't even have to do anything. You can give it to us as a problem. Cool. This is a positive velocity, so we're moving in a positive direction. Now let's calculate our acceleration. So Vf minus Vi over delta t. So 8 minus 12 over 2. So this will give us negative 2 meters per second squared. So that was a negative acceleration. So now the last one, negative 4 meters per second to negative 8 meters per second. So the velocity is negative. It means you're moving in a negative direction. Now let's calculate the acceleration. So Vf minus Vi over delta t. So we have negative 8, take away negative 4 over 2. And this will give us negative 2 meters per second squared. So this is going to be negative. And in this case, you're speeding up. You're just going from negative 4 meters per second to negative 8 meters per second. So in a negative direction, you're just getting faster. Cool. So now let's go ahead and summarize this. So interesting. If the sign of the velocity and acceleration is the same, So they're both positive, it's speeding up. Or if they're both negative, you're speeding up. Well, the opposite is true. If, let's say, the velocity is negative and the acceleration is negative, then you're slowing down. And same here. So if velocity is positive, acceleration is negative, you're slowing down. So always think about, just because you have a negative acceleration does not mean you're slowing down. That's a common myth. Whether you're speeding up or slowing down just is determined by how your velocity and acceleration signs are, if they're the same or different.